Okay, so now we're going to look at example 2, where we use the Pythagorean theorem to kind of find and answer some missing sides and stuff. I'm just opening up the calculator so I have it when it loads. All right, example 2. In the following triangle, AB is equal to 9. So again, immediately I'm just starting to label stuff. AB is equal to 9. BC is equal to 14. Find AC to the nearest tenth. So this is what we're missing. So notice we're missing that hypotenuse, which, again, we're going to be using our Pythagorean theorem for this, which I'll write at the top. A squared plus B squared equals C squared. So in this situation, since we're missing the hypotenuse is that C. That's that piece we're missing. So A squared plus B squared equals C squared. And again, it doesn't matter which one, A or B, is 9 or 14. I'm going to go 9 squared plus 14 squared is equal to C squared. 9 squared gives me 81. 14 squared is 196. And then that's equal to C squared because that's the piece we're missing. So 81 plus 196 gives me 277. Did not read that correctly. And so now this is a little bit of review from stuff that we did last year. Oh, geez, sorry. Here, I don't have the C isolated yet. Here, we need to solve for C by using that square root. The opposite of a square, or the inverse operation of a square, is square rooting both sides. So this is where we go to our calculator. Second square root of 277. And remember our decimal rules. Write down at 3 decimal points or 3 decimal places, the ... and then you can round. So 16.643. So 16.643 ... is equal to C. So now we can go back and do the directions. The directions asked me to round to the nearest tenth, which would mean that I have AC being equal to 16.6. Because I rounded to the nearest tenth. That 4 keeps it where it is. And that is how you use Pythagorean theorem to find a missing side. Notice here they didn't give me any angles and there was no talk of angles, which is why we knew to use Pythagorean theorem and not trigonometry.